Okay, our third case is when our object for a concave mirror is between the focal point and the actual mirror. So I'm going to put that right there. So that's my object. So the problem is that if I were to do my normal thing, I'd go from here to the mirror through the focal point like that, and I'd go through the focal point like that. Don't even bounce off the mirror, but I go, and you can see that these are diverging, so they don't cross anywhere. So that's not going to work. So we have this. Well, you go back to the focal point like that, and this one goes like that, parallel. Okay, so we go through the focal point, so sort of, but we go backwards. And then the other thing is the center. This goes like that, and we carry that on, if I remember correctly. What do we do here? I always forget how to do this. That's why I do it a number of times. Okay. So I'm trying to remember this without cheating. So let me think here. So we kind of extend this one upward like this. Is that right? No. Okay, let me erase that. So we take this through the center like that over there, okay. And so we do extend this one out like that. So we have the intersection of this one, which is the continuation of this ray, but back behind. Likewise, this one would normally bounce off and come backward here, but we extend that as well. And the intersection of those 2 points corresponds to the head of that. So we can draw our image like that. So this is the object. This is the image. And so what can we say? Well, we could say the image is not real, but it is virtual. I forgot what that was. Virtual. It's upright because it's in the same direction, pointing in the same direction as the object, and it's magnified because of the fact that the image is greater in length than the object. So that's how that works. And you can see, I think, if you put this closer to the focal point, it's going to make these lines go more in this direction. So if I were to move the object, let's just do it again. Let's erase all this stuff and just move the object again. So we're going to move it closer here, right to the focal point. So again, you have a line that goes from the focal point through the tip, and then you would have this go out this direction, but that doesn't work. So we extend this into the other side of the mirror, and then we have from there to the focal point, and then we extend that again behind the mirror so we can get an intersection of points. And I actually have to extend this one out a little bit further to about there. And so that's how that works. Now let's try one more thing. Let's see what happens. If I were to go from here to there, and then I think if you draw that line from where the image is, you would also get to go through the point. So it does. So this angle theta is equal to that angle theta. But again, we're drawing this line, this dashed line, behind the mirror, and they all reach the same point. So again, the closer you move this thing to the focal point, the larger the magnification. And we will look at that in a lab. So before we move on, let's just look at a few pictures that are in one of the books I have. So this is explaining if you have an object, this is the object, that's between the center and the focal point. The parallel ray bounces off the mirror through the focal point. The ray that goes through the focal point bounces off parallel. So ultimately our image is back here, which is inverted, it is magnified, and it is real. You can see the rest of it. So there it is. That's their picture, and right there. And so the ratio of HI over H0, image to object, that's what INO stands for. You can see it's bigger. And D0 is the distance. So there's a couple of dimensions here that I haven't mentioned before, because we can use those to see what the magnification is. So if you take the distance from the mirror to the object, which we'll call DO for D object, and the distance from the mirror to the image is DI, the ratio of those distances will be the same as the ratio of the heights. I think that's the way it works out. So let me write that down. So I think what we can say is H0 over HI is the same as D0 over DI. And actually the reciprocal of those would be the magnification. So we can also say that H image over H object is equal to the distance of the image from the mirror divided by the distance of the object from the mirror. Did I do that right? Yes. Image. D sub I. Yep. Okay, and then the other one picture is this one I just showed you. So what they're showing is they have the object. You draw a line from the center through the tip of the object. You just continue that straight. That's one line. The second line is you go through the focal point and you bounce, reflect it parallel, but you then extend this line parallel to here. Those are 2 points. The third point they have is if you go through the focal point to where the mirror, if you draw a parallel line here and go through the focal point, you extend that line and you get to that. So that's one I did not include. And then what was the fourth one I did was you take from here to there, and if this thing bounced off, if you extend this backwards, you'll find that also matches up. So there are the 4 lines that we normally have that still are applicable.